Let's take a quick tour of the 1730. We'll start at the back here. We have a kickstand which allows the instrument to stand up quite nicely when it's on a bench or when it's in a panel. This part at the back here is a power supply, and this is detachable like this. Underneath this panel is the battery pack which powers the instrument for around 4 hours. The purpose of having this detachable power supply is that it allows you to place the power supply in a separate location to the instrument if you've got tight space inside the panel. The package comes with a cord which goes from the instrument here to the power supply, so they can be easily separated. This just slots back on like this. Here, this loop can be used for the hanging option to hang the instrument up inside the panel. If we look at the top of the instrument, we see that we have some inputs here for voltage. So this is three-phase voltage A, B and C. And just going back to the power supply, we see that we have a standard power cord input here which plugs into wall outlet. But underneath here we have some more 4mm sockets. And these can be used to power the instrument in conjunction with the voltage inputs here. So we can take the voltage which is being measured by the 1730 and use that to power this power supply. So these are voltage inputs here, A, B, C as I mentioned, plus neutral. Below that we have inputs for current, so A, B and C again. This is a new type of accessory that we've designed specially for the 1730, which is a new thin flex which goes into here, and the instrument reads those automatically. We have three standard types of flexes. We have a 1500 amp which is supplied normally with the standard instrument. We have a 3000 amp one which is 24 inches long, longer than the 1500 amp one, and a 6000 amp version 2 which is 36 inches long. We have more inputs other than just voltage and current. We have this analog input here which is for DC voltage, and we have two of those. Now that can take up to 0 to 10 volts DC. The purpose of those is to take other signals which represent things like temperature, or pressure or airflow, and those will be logged at the same time that you're logging the power that's being measured. At the end here we have USB ports. The first one is a standard USB for connecting via a lead to a PC, which can be used for downloading data and also for upgrading the firmware on the instrument. The second port here is a USB port which can be used in conjunction with a memory stick which is supplied with the instrument, and this can be used again for downloading data and upgrading. The nice thing about this port, it means that you don't have to take a laptop to site to get information out of the instrument. The last port we have here is the extension port. The extension port isn't currently used, but this will allow us to expand the functionality of the 1730 in the future. So on the front of the instrument we have a set of buttons for selecting display functions. We have function keys along the bottom which select items in menus, and we have some controls here, cursors plus enter. We have the brightness button here, and we have the power button here. The display, in addition to showing measurements, is also a touch screen, so this can be used for controlling settings and looking at information as the instrument comes on. When you power the instrument up for the very first time, it goes into a menu mode where you have to make local settings based upon your region and your preferences for the first time you use the instrument. Once you've set these, you probably never have to use it again. So here's the first menu item for selection. It's the language for the instrument. We can choose this either by using the cursor keys by going up and down, or we can just touch the item we want, like English for example, and then we press enter, and it takes us to the next thing, which is the colour coding for the country that we're in. Now we can either select enter, or we can select next here, or we can select next on screen too. Next selection is the time zone, and we'll choose Americas. There's a very comprehensive list of areas of the world where this can be used. So there's the Americas, and press enter. Now we choose the time zone. In this case there's a lot of different choices, so we'll go up in this case so that we get to the United States first and press enter, and then we choose our time zone for the country and we'll choose Pacific time and press enter. Now we can choose the date and time format. Now the date format is the default one here, which is month, day, year, which we're most likely to use, but we also have a selection of the 12 or 24-hour time available too, so we can either go to AM, PM or the military style 24 hours. We'll choose the 12-hour one in this case, and then we'll press F4 for next. Now we can choose the date and time manually on the instrument. We use these buttons here to increment or decrement depending on what we want to do for the hour or day or date. And once we're happy we've got the right one, we press enter, and then we're ready to go to the currency selection. The currency is here because we can give a price for the cost of kilowatt hours so that we can calculate what the cost of energy is consumed during a campaign. And we'll press the finish button on screen, and now we're ready to measure. Here we've connected up to a power source, and we can see that we have some voltages and currents present, so they're being measured. When users use the instrument, they should always check to make sure that they're connected the right way. Sometimes that's difficult because you're inside the panel and maybe you're live working with a suit on and mistakes get made. But we have the verify connection system here, which will automatically check that we're connected up the right way. To initiate that, we just press the verify connection button, and then on screen we see the voltages, the currents, and there's an indicator here which suggests that one of the current sensors is connected the wrong way around. In the past you'd have to go back inside the panel to change that so it's corrected. What we can do here is that we can automatically correct this. So we'll press the auto correct button, and then the instrument works out what it should do, and it's now changed that connection for that current sensor. We can take a look at what that's done by pressing the correct digitally button. And what it's done, it's inverted the current input so that it's effectively switched around electronically. So now when the user goes to use this in the logging mode, he'll come back and he'll have good results rather than incorrect results after, say, days or weeks of measuring. Logging data with the 1730 is really easy. We just press the logger button to start logging, and there's just a few things that we just need to check before we press the start button. We check that the name of the file that we're going to create, how long we're going to log for, in this case 1 week, how often we calculate the average, what the demand interval is. The demand interval is important. This collects the energy values. Unless the user doesn't need energy, this value should not be set to 0. I recommend it should be set to at least 5 minutes, then it will collect energy values for every 5-minute period. Next we have the energy cost if you're interested in what's cost over the series of the campaign, and then we have a description down here. For this example we'll just accept those values as they are, and we'll press start logging, and then the instrument will start collecting all of the values. There is a message at the top of the screen which indicates when the session will start. The values are now being built up over time, and then we can take a look at those once we have some values. Here we can see energy as it's being logged. This is the graphic which is shown by default on the logger screen, which is the kilowatt hours being consumed. We can also browse through other values as well, such as volts. Here we have a tabular view of the data which shows us when the min, max and average values occurred. We can go back and we can take a look at energy. So this is kilowatt hours, and here we show that as a split across all of the phases. So we have the total value for all 3 phases, and then each of the separate totals for each phase. We can also look at other values as well. So we can say look at kVA hours, and again it shows us in the same kind of format. And then we can go to the home screen, select another value like power for example. Here we can see the tabular version of the power. In this case this is power factor. Again we have the menu which allows us to select one of the measured values, like kilowatts for example, and this shows us the totals and when the top average value has occurred in this list here. We can also download data at this point while we're still logging, and all we need to do that is just plug in the memory stick in the top corner there, and automatically the instrument recognises the fact that we've installed the USB stick ready for downloading data, and it comes up with this copy login sessions to USB. We'll select enter, and then we have the list here, short list of values that are available inside the instrument, and we'll choose number 5. This is the one which is currently being accumulated, and then we press save to USB stick, and it's now saving those values. Continue to log, so we could leave this for a week and then we can just take a couple of days of data just so we could get a feeling for what the data is about. And it takes a few seconds to download that data. There's a lot going on the instrument right now, so we're still making measurements, we're still creating all the average values, and we're still writing to this USB port, so it just takes a short time to do this. It's not instantaneous. And now that's complete, so we can remove the stick and take that to the software.
This is the opening screen of Energy Analyzer. It's got a minimum of controls here. The first thing that we're interested in doing is downloading data, either from the instrument or from memory stick. Depending upon what's connected, the software will recognise the opportunities for different kinds of files. In this case, it knows that there is a USB stick connected and it's got this data on here, and we select the data, we can tick the box here, and then we download, and now the information is being taken off the stick and pulled into memory. This first screen gives us the background to what the measurement is about. We can see that it's an energy study, we can see that it's 3-phase, and it gives us the period that this was measured over. The tabs at the top provide other information about the data we have. So if we click the Energy Study tab here, we see that we have a graph of energy that goes across the screen. Here we can select which energy we want to see. We can choose the channels here, so A, B and C by totals. We can also choose apparent power values if we wish, and also the VARs. We can click as many or as few of these as we need for our study. On the right hand scale we can also display power factor as well simultaneously, so we can mix and match exactly what's on the graph. Here I've loaded up some new data which will show you how the graphs look. So this one is an RMS power graph that we've already seen. If we go to the next tab along here, we can see what the demand looks like. Next we'll take a look at the calendar view. The calendar view represents longer periods of information on the small thumbnails. This is useful for seeing the rhythm of a facility. So in this example, the facility was connected up on Friday here, and then we used power on Friday, but then Friday evening it went off, and then over the weekend very little was used, and then Monday became the peak day for energy in the facility, and then we see Tuesday cycle, Wednesday, Thursday, and then we see tailing off again on Friday. So this quick overview is a nice way to get an idea of what's going on in the facility. We can also look at fundamental power instead of RMS power, which could be an interesting analysis of what's going on with harmonics as well. And here we have the volts amps hertz tab, so we can graph all of these parameters quite easily, which can come in very useful for things beyond energy savings. But what we'll do now is that we'll look at how to make a report. So we'll start off with the calendar view, and we'll add this picture to our report. So we'll click on bookmarks, so we add the bookmark, and now this will be available for us to put in our report. We'll go to the RMS power tab, and we'll look at the 3 phases of power so we can compare them, and we'll add a bookmark, and then we'll go to the next tab once I've turned these off, which is the apparent power. We'll now add some power factor information to this same graph. We'll add just phase A here and then turn off B and C. So we're looking at power factor for phase A along with the power, and we'll bookmark this now. Next we'll do that for B and bookmark it, and then we'll do C and bookmark that too. So we've started to build up a set of screens and so on that we're interested in. We can also look at the information in a tabular format like this. So here we can see the active power for this incomer, and we have A, B and C, and we have the totals here, and we can add that to the bookmark. And we'll do the same now for the demand. We'll look at the demand table. This tells us how much energy we used in this case, and we'll just bookmark that. And we'll also look at the RMS power table, and we'll add that bookmark. So now if we go to the report tab here, we can see that we have some information in the project manager, which is the opening tab. We get the summary of information. We have text here that we can input and change. It gives us information about the instrument. Here we have our bookmarks that we created, and we can now add these to the report. So you can see the tab that when we looked at the tab before, the calendar view, this is what we saw. And we'll add this next section. Or we can also remove those as well very easily. And then we'll add some graphs like this. We'll add the RMS power table, and we'll add the demand table too. So that's our report. Really easy to create, and we can now make sure that we keep a copy of that by saving as, and we'll call this demo data 1. Now the next time we come back to this file, we can still manipulate it, and we can still do more to this report and add or subtract just as we feel we want to do.